Good day, my name is Dirk Wesselman. I'm a mining, industrial and engineering professional who's been in the industry for the last 30 years. I will be making a whole range of videos to illustrate the good practice of returning to good engineering practices and standards. All the content in this video I credit to Mechanical Engineering Learn on the LinkedIn forum. The intent is not to copyright any of, or to infringe on the copyright of any of this material, but to use this material to ensure that we can benefit from returning back to good mechanical, industrial and engineering practices. Today I'll be handling centrifugal pumps, which many people oversee and oversight, and the importance of the equipment. So I'll dive right into this presentation. If you'd like, at the bottom of this video there will be a contact page and a contact number that you can make contact with us. So let's dive into centrifugal pumps. The workings of a centrifugal pump. The working of a centrifugal pump is any machine that provides energy to a fluid is termed as a pump. Generally, in pumps, electrical energy is converted into hydraulic energy. Pumps are energy absorbing devices since energy is supplied to them and they transfer most of the energy to the fluid. Pumps are widely used for domestic and agricultural purposes. They are also very much in use in the petroleum and petrochemical industries. Pumps belong to three categories. First, positive displacement, second is centrifugal, and the third is axial flow. In positive displacement pumps, the liquid is sucked in and then it is displaced due to the thrust exerted on it by a moving member, which results in lifting the liquid to the required height. Piston, plunger, diaphragm, gear and vane pumps are examples of positive displacement pumps. Centrifugal pumps are the most commonly used pumps in the world. A centrifugal pump converts rotational energy provided by a motor to hydraulic pressure energy, causing the liquid to rise from a lower level to higher levels. A pump consists of several components, such as an induction motor that is mounted at the back, a shaft that is connected from the motor to the pump, and an impeller that is mounted to the shaft. The impeller is placed inside a completely sealed casing. The casing has a volute that it is present on the periphery of the casing. The part through which water enters the pump is known as suction line, and the part through which the water goes out is known as a discharge line. When pumping liquids, it is sometimes possible that the local pressure inside the pump falls below the vapor pressure of the liquid. If the suction pressure is only slightly above the vapor pressure, some of the liquid may flash to form vapors inside the pump. These vapors may then collapse, causing damage to the pump. This condition is known as cavitation, and it should be completely avoided in order for the pump to function efficiently. In order to prevent this, water should always be filled in the impeller and suction side. This is known as priming. The general requirements of a pump is to transport liquids from low pressure regions to high pressure regions. The induction motor provides electrical energy and rotates the shaft, which causes the rotation of the impeller. When the impeller rotates, a region of low pressure is generated and the water is then sucked into the pump inlet from the reservoir. Any fluid naturally moves from a region of high pressure to lower pressure. The water then enters the impeller action. The rotating impeller pushes the water outward to the boundary and then towards the volute section. The volute area keeps increasing from its starting point right up to the discharge line, as per mass conservation principle. Mass flow rate through any section of string tube is constant. Therefore, velocity and area become inversely proportional to each other. Thus, as the area keeps increasing, the velocity of the flow decreases, and hence its kinetic energy decreases. As per Bernoulli's equation, decrease in kinetic energy results in increase in its pressure energy. This increase in pressure head causes the liquid to rise to the desired height. Okay, and that concludes our lesson for today regarding the centrifugal pumps. Hopefully you do have a better understanding of the workings of a centrifugal pump, and that the information is valuable to you and to your organization. So in our next video we will more intensely handle specifically slurry equipment, slurry pumps, and the vertical slurry pumps. So stay tuned for the next few videos that will be released. We will try to do it on a weekly basis. Let me know if this video has been helpful, or if there is any specific topics that you would want me to discuss regarding this wonderful forum that we've created. And please feel free to forward your engineering videos and your engineering expertise to us at dirkwesselman@gmail.com, where we will look at the content and we will gladly publish any information and videos that is worthy to increase our efficiency and to ensure that we return to good engineering practices. Thank you so much for listening. Looking forward to talk to you soon.